Okay, this is the third video for section 10.2, and we're kind of done with combinations. Now we're going to focus on the binomial theorem. And you probably want to make sure you take some decent notes. The binomial theorem is really just a pattern, so if you're good at following patterns, this should not be challenging. However, it's quite a lengthy pattern, so make sure that you take some time and write down some good notes. So first of all, we're going to talk about a couple things, and you don't necessarily have to write down either one of these yet because I'm going to go through these in detail. But the first concept we're going to talk about is Pascal's triangle, and I just want you to know that Pascal's triangle is really going to be optional. Some of you are really going to like it, and some of you won't. All it is, it's a pattern, so it's an arrangement of all of the combinations, and it makes a triangular pattern. And each row corresponds to a value of n. So if I had like 10 for n, that means I would have, 11 rows actually, and you'll see why it's 11 and not 10. And then that can apply to the binomial theorem, so some of you might use it, might not, and you'll see when we get there. But this is the binomial theorem. Now don't frantically write this down quite yet, because I really want you to understand what all this stuff is. But you're going to be expanding a binomial, so this might be like x plus 2 to the 10th power. Well, you don't want to FOIL something out 10 times, so you're going to use this really cool binomial expansion formula so that you don't have to FOIL it out 10 times. All it does is it takes combinations from whatever power you're at, so let's say this were to the 10th, and actually I can write in some numbers, so let's say I had x plus 2 to the 10th power, my n would be 10. Okay, so I would do like 10 choose 0, 10 choose 1, 10 choose 2, all the way up until I got through 10 choose 10. And then your a is the first term, so in this case my a is x, and my b is your second term, so in that case it's 2. So I would just do a, which is x, so x to the 10th, x to the 9th, x to the 8th, blah blah blah, all the way down to x to the 0, which is just 1. And then your b value, you start at the opposite end. You start at 0 and work your way up to the 10th power. So b to the 0, which is just 1, b to the first, b squared, well actually it's 2. So 2 squared, 2 cubed, etc., all the way up to 2 to the 10th. And I will work out an example, obviously. Okay, so here's Pascal's triangle. And the first and the last numbers in each row are always 1s, and every other number other than 1 is the sum of the closest two numbers in the row directly above it. Now, before I fill in the numbers, I want you to see the pattern because it's actually quite simple. The 0th row is 0C0. The first row is 1 choose 0, 1 choose 1. The second row is 2 choose 0, 2 choose 1, 2 choose 2. So basically you're always starting at 0, and you're working your way up to n. So 3, 0, 3, 1, 3, 2, 3, 3. So the fourth row would be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, etc., etc. So if I fill these numbers in, and I would just dump these on my calculator, this isn't magic. So 0 choose 0 is 1. Okay, so this is a 1. 1 choose 0 is 1. 1 choose 1 is 1. 2 choose 0 is 1, and 2 choose 2 is 1. So anything choose 0 is 1, and anything choose itself is 1. So basically you're seeing already that these will always be 1s on the outskirts of the triangle. And then the two numbers here will always add up to the 1 below it. So 1 plus 1 is 2, so that's going to be a 2. Or I dump on my calculator, 2 choose 1 is 2. These two add up to 3, so that's going to be a 3. And 2 plus 1 adds up to 3 also there. So really when n equals 4, without filling out 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, I know that it's going to be a 1 and a 1, and then these add up to 4, these add up to 6, and these add up to 4. And you could keep going as long as you need to. Now, what do these help you with? Well, these are, you'll use these for the binomial expansion theorem, which I'm going to talk about next. So I'm going to follow up on this, and then you're going to decide if you want to use it or not. You really don't have to use it. One last time, when n equals 5, the triangle would be, again, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and what do we got? 4 plus 1 is 5. So there would be the fifth row. Okay, what does this give you? So this is for the binomial theorem now, which again says take any binomial like x plus 2, raise it to any power you want, and you can use this formula to expand on it. Notice these combinations n choose 0, n choose 1, n choose 2, all the way up to n choose n. So if you have a fourth power, you're going to, so I'm just going to make this up, let's say you had x plus 2 to the fourth, you're going to have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4 for just these pieces, right? Well, Pascal's triangle says that means you should go to the n equals 4 row and pick out those pieces. So if you like Pascal's triangle, then you would just know that this is 1, 4, 6, 4, 1. Okay, so what does that help you with? It's just, so Pascal's triangle is just a shortcut to get you these combinations. If you don't like Pascal's triangle, then you would just dump these on your calculator, which I talked about in the previous video, and you would get 1 and 4 and 6 and 4 and 1. So totally up to you. I am going to expand using the binomial theorem on the next slide here and explain how it works. Okay, so here we go. We'll start out with a smaller one. It says x plus 4 to the third power. Okay, so first and foremost, you have to note that your power, which is always n, oops, is not 4, is 3, because it's cubed, right? And then your a and your b are your two terms in that order. So a is x, and b is 4. So when you use the binomial expansion, it's just, again, it's just a pattern. So I'm going to note my power, and I'm going to start there with my combinations. So it always starts with choose 0, choose 1, choose 2, all the way up to itself, 3, choose 3. Okay, then you move to your a value, which is x. Okay, and you're multiplying all of these together. So I'm going to take x and you raise it to the power of 3, and then you go down to the power of 2, down to the power of 1, and down to the power of 0. And then lastly, you move to your b value, which is 4, and you do the opposite pattern, still multiplying all of these. So it's 4 to the 0, 4 to the first, 4 squared, and 4 cubed. Then you add together all of these pieces. Okay, so I'm going to rewrite these here, and I'm going to start by, these are just numbers, right? So I'm going to start by calculating those. So 3 choose 0 is really just 1. Whoops. And that's times x cubed, and 4 to the 0 is really just 1. Okay. And then 3 choose 1 is really 3, x squared is x squared, and 4 to the first is really 4, and I'll simplify that in a second. Plus 3 choose 2 is also 3, times x squared, I'm sorry, not x squared, just x to the first, and then 4 squared is 16. And the last chunk, 3 choose 3 is really just 1, x choose 0 is really just 1, and 4 cubed is 64. Now I'm going to simplify all of these. So 1 times 1, of course, is 1, so that's just x cubed, plus 3 times 4 is 12, so that's really 12x squared. What do we have? 3 times 16 is 48, so that's really 48x. And 1 times 64, that's easy, 64. So if I had FOILed this out 3 times, I would get this, which might actually be quicker because I know that you're pretty good at FOILing something only 3 times. But if this were to the 6th power, this expansion formula is probably a little bit quicker than FOILing something out 6 times. So again, whatever your power is, you start there, choose 0 all the way up to itself. Take your first term to the power of 3 and work your way down to 0, and take the second term to the power of 0 and work your way up to the degree of 3. You multiply all those together and then add the individual pieces. Let's try another one. Okay, this one I want you to try on your own, but the first thing I'll note is that it's 2m minus n, so I've also rewritten it as quantity 2m and then plus a negative, because that subtraction is actually going to work like a negative n, and your power is the 4th power. Okay, the other thing I would comment on is the 2m is a quantity. So for example, if I take 2m and cube it, that's going to be 8m cubed. So be really careful with that, because you cube the 2 and cube the m. Also be careful with negative n's. So if you have negative n squared, that's actually a positive n squared, because you're squaring the negative. If it's cubed, it's going to remain negative. So really, really be careful with this one. It's a little bit trickier. So pause the video, see how you do. Okay, I kind of have everything written out here, and then I'm going to finish my simplifying. But it is a 4th power, right? So I knew that I had to do combinations starting with 4, choose 0, all the way up to 4, choose 4. Then I took my first term, which is 2m, and make sure you write that as a quantity, and I took it to the 4th power and then worked my way down all the way to the 0. And then my second term, which I made a negative n since I'm subtracting, I raised that to the 0 power and worked my way up to 4. So notice the pattern, right? Your degree, starting with 0, working your way up to 4, starting with 4, working your way down to 0, starting with 0, working your way up. I mean, it's definitely a pattern. Okay, then mistakes can occur still. So first of all, this, if you use Pascal's triangle, you go to n equals 4 row, which would be 1, 4, 6, 4, 1. So that's where these came from. Or dump these in your calculator and you'll get 1, 4, 6, 4, 1. Okay, then 2m to the 4th, be careful, is 16. 2m cubed is 8m cubed. 2 squared, 4m squared. To the 1st, anything to the 0 is 1. And then the negative n, be careful, the negative n to the 0, of course, anything to the 0 is 1. Negative to the 1st is going to stay negative. Negative n squared will turn positive. Negative n cubed will stay negative, and negative n to the 4th will turn positive. Okay, now I thought I'd do my last simplifying with u. So this will be 1 times 16 times 1, which is just 16 m to the 4th, and I'm going to add my pieces together. So 4 times 8 is 32, times a negative would be negative 32. So make sure you don't disregard that, and that's, let's see, m cubed n. My next piece, 6 times 4 is 24, so that's a plus 24 m squared n squared. 4 times 2 is 8, times a negative is a negative 8, and that's m n cubed. And my last piece, 1 times 1 is 1, so I just have n to the 4th. What I see a lot of times here with negatives is people will write like 32m cubed minus n, but it's not minus n, right? They're all being multiplied together, so be really careful. That negative n will just make your number out front negative, and it should always alternate, positive, negative, positive, negative, positive, when you have a subtracting problem. So a lot of work, but I promise you when you get used to this, it's pretty slick process.